Let's do some more. We have vector b equals 5. Magnitude of the vector is 5 at 143 degrees to components. So x, we're going to do magnitude cosine theta. Magnitude cosine theta gives me my x component. Magnitude sine theta gives me my y component. Make sure you're in degrees. Another c into positive and negative. Oh, into these components. Well, we are given the components, so we want to figure out what is the actual length of the vector. To do that, we're going to use Pythagorean theorem. We have our x right here, we have our y right there. So x squared plus y squared equals c squared. So c will come out to 7.1. Try these, make sure you can do them. Very easy. And then we're going to use the direction formula. Theta equals arctangent y component over x component, or opposite over adjacent, right? Seventh line, negative 45 degrees. All right, do this one. Pause it, try it yourself. Pythagorean theorem, again, so we get 9.4. Inverse tangent of the direction formula, tan theta equals y over x. Formula is not given to you. You have to kind of know that. Tan theta, arctan equals y over x. Arctan equals y over x. If you want to see the derivation of that formula, go back a video. Uh-oh! Vector d doesn't point anywhere near negative 32 degrees. That's because the inverse tangent lies to us when the x component is negative. We need to add or subtract here to get 180 to get the correct direction, which is 148. Remember? Okay. So now that we have these different vectors, we can add vectors. Just like normal numbers, we can add any number of vectors. So we can do 10 vectors, we can do 4 vectors. The sum itself is a vector and is called the resultant vector, or resultant for short. Just like normal numbers, vectors can be added in any order. The resultant is the same no matter what order we add the vectors in. Looking at it graphically, we've got these 4 vectors. If the grid on the left shows A, B, C, and D. To add vectors, we're going to slide the vectors around so they make a path as shown on the right. Note the vectors do not change length or direction as we slide them. The vectors can be in any order, but the path starts at the origin, and the vector starts where the previous vector ends. This is called the tail-to-tip method, or tip-to-tail method. Tail-to-tip is probably better. So what that means is we're going to start with vector A, starting at the origin, and we draw vector A. Then we're going to take vector B, and we're going to slide it on over so the tail end of B is touching the tip end of A, tail to tip, as you can see here. Then we're going to do the same thing with C, and we're going to move C so the tail end of C is touching the tip of B. Right there. And then finally we're going to do the same thing with D. We're going to slide it on up so the tail of D is touching C. Now the resultant vector is this white vector. It's the arrow from the end of our starting point, or from the starting point to our ending position. The resultant, the sum of the 4 vectors shown in the right diagram as the white arrow, is the vector that points directly from the starting point to the ending point. The resultant is the shortcut that goes straight from start to finish. So if you want to think about this as a directional thing where you go up, you go northeast, and then you go northwest, and then you go southwest, and then you go straight south, where are you? You're right there. Another way to add vectors, the parallelogram method, is another method, but this method only works if you have two vectors. Meanwhile, the tail to tip always works. So you choose what you like. All right, so here we go. Suppose we want to get the resultant of vectors A and B, shown on the left diagram. To do this, first of all, the two vectors have to start from the same spot, and then you draw them at the correct length and angles. To do this properly, you really need a ruler and measure out the exact length of each of these vectors. So you would scale down the length. So if it's 10 meters long is the first vector, you can scale that down to 10 meters equals 10 centimeters if you want. And you can say 1 centimeter equals 1 meter. And then you can rearrange it. And if you do that precisely and take your time with it, it's going to come out perfect every time. All right, parallelogram method. We're going to start with both the vectors starting from the origin. You draw them correctly, and then you complete the parallelogram. Remember, parallelogram means we're going to have a parallel right here, and then we're going to have parallel right here. Parallel to A and parallel to B. And the resultant is going to go to the corner of the parallelogram. This is useful in qualitative exercises where you need to determine the direction of two given vectors, for instance. The resultant is the vector that cuts diagonally from the origin to the other corner of the parallelogram. Now we have numerically. We can't add vectors in the form of magnitude at direction. We can only add vectors using their components. The vectors below are A equals that, B equals that, and C equals that, and D equals that. The x component of the resultant is the sum of all of the x components together. So the x component of the resultant is positive 5, negative 3, negative 7, and 0. X, Y. Alphabetical, right? In case you forget. So your x, 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 x. The y component is the result of the resultant is the sum of the y components of each vector. So the y component of the resultant is the y, the y, the y, and the y, all added together to get negative 3. So now we have an x component and a y component for our resultant vector. It doesn't give us our magnitude of the resultant vector, though, does it? No. From here, if you want to figure out the exact length of this, remember this is the x component is negative 5, and the y component is down 3, negative 3. So that's our right triangle. So to get the resultant vector, we have to use the Pythagorean theorem. So it would be square root of 5 squared plus 3 squared. Or, yeah, either way. Squared so the negatives go away. So that would give us our resultant length. To find the direction, then we would use arctan equals y component, negative 3, divided by x component, negative 5.